Hey guys, our goal this year at dream10x.com is to read 52 books in 52 weeks. And each week we're going to present our 5 key takeaways from each book. And then we're practically going to give the book away for free at dream10x.com/store. So if you're interested in any of the books that we're reviewing here at dream10x.com, just go over to dream10x.com/store and click on the Stripe link to use whatever credit card you want to buy the book. That you can get it at practically shipping cost, and we'll send it to you right away. Thanks a lot. We really appreciate your support. Hey, it's your boy JC, and welcome to the Dream10x podcast. This is episode 83, and this week we are missing my lovely co-host, Dr. Capel. She's in an undisclosed location. And she should be back on by the next episode, hopefully, if all goes well. No, she'll be back. But before she gets back, I just wanted to talk about the next book for this week, which is 1,000 Brains by Jeff Hawkins. And Jeff Hawkins is a neuroscientist, researcher who actually is the creator of the Palm Pilot. And I don't know if you remember way back when in the mid-90s, Palm Pilots were the popular handheld mobile device. He also wrote the book on intelligence, which we reviewed back in June of 2022. So this book is kind of an evolution. This book is an evolution of this book, and a lot of the same ideas are in this book. But it's just a little more refined, a little bit more information in there. So here are my top 5 takeaways from this iteration of the Jeff Hawkins book, 1,000 Brains, A New Theory of Intelligence. Number 1, this book was published in 2021, and this book was published in 2004, so there's a good amount of time between these two books, and ostensibly during that period, Jeff and his team have been doing a lot of research on the brain and how it works, and he's just building on additionally to the information that he initially got from Vernon Mountcastle. Vernon Mountcastle was a researcher who did a lot of brain research as well, that Jeff Hawkins was basing a lot of his research on. And one of the big takeaways from Mountcastle was that the neocortex, the new rind of our brain, which we talked about in the last edition, it's just the neocortex is like a big flat napkin that has a bunch of cortical columns in it that are kind of like little pieces of spaghetti that are all stuck together. And that napkin-sized neocortex is all folded up inside of our brain. And those cortical columns are really the fundamental pieces, the fundamental components of architecture that make us intelligent. They're the pieces of the brain that actually formulate intelligent thought and thinking. And the neocortex is what makes sense of all of the sensory data that's coming into our brain, into our dark skull from our eyeballs and from our ears and from touch and wherever else. And so Vernon Mountcastle, the research that Vernon Mountcastle did, which he published in 1978 in his book called The Mindful Brain, the research that he did in that book provided a lot of information for how Hawkins and his team have conducted their research moving forward. And so he's kind of like building on the shoulder of giants kind of thing. So the cortical columns, there's about 150,000 of those cortical columns in our neocortical napkin. And those are, like I said, those are basically the building blocks of intelligence. And so we've already talked about that when we talked about on intelligence, but he's just kind of refining those principles a little bit in this book, and providing a little bit more information. The other interesting thing that I pulled out of this about the cortical columns is that architecture, I won't call it hardware, that's wetware architecture, that is the cortical columns in our brain. they are the same pretty much throughout the neocortex, regardless of what their function is. So if their function is to like interpret vision signals, the structure is roughly the same when you compare those to the auditory sensing structures, as well as taste and all this other things, language and all that. They're a little bit different according to the book, but those cortical columns are pretty much the same architecture throughout. So he brings up a question in the book like, okay, so all of these cells are pretty much the same regardless of what they do in our brain, in the neocortex anyway. What is it about that similar architecture that allows them to do so many different things? And I just kept thinking, well, it's the software. It's the software that's running in that wetware that allows it to do specialization based on what data it's trying to interpret. Maybe, I don't know. That's just what popped into my head. The brain started out in the old part of the brain. So there's a number of different layers of the brain, and we've talked about this already, but the old parts of the brain, like the amygdala and some of the other parts. The neocortex means neurine, so that's like some of the new evolutionary parts of our brain that give us Homo sapiens, wise people, intelligence. The older part of the brain makes us more like amphibians, and it's part of our deeper evolutionary past. And that part of our brain is more concerned about survival, fight or flight, that type of thing. But that part of our brain also has an awareness of location, which I thought was really cool. Even in humans, you've heard about birds that have certain cells that can help them find north and south and fly south during the winter and go to their common grounds that they're used to. And that's pretty interesting from a biology standpoint. How do cells do that? How do they know where to go? How do they know what direction is south? How do they know exactly how to find a certain nesting ground and all that kind of thing? But it is a biological thing, and humans have it as well. He calls it spatial mapping. And it's not so much that our old brain is so much aware of lat-long coordinates, exactly where we are at any point on Earth. It's more of, we build a map of the world as our brain learns. So I know that I'm sitting here in this chair right now in my basement. I know generally where my house is, and I am further aided in knowing and building a model of my location of my world by maps, by digital maps, and that distributed computing that we use in terms of maps, digital maps, helps me build a model of where I am at this point in the world. And I can refine that model by moving around in this world. And so that is one of the earliest evolutions that we have in our old brain that actually migrated into the cortical columns as well. So our neocortex is able to build those maps as well. Interesting. We have mapping software and hardware in our brains. In the old brain, structures like the hippocampus and the entorhinal cortex are responsible for kind of mapping and mapping out a location awareness to our environment. How did I get to 4 already? Okay. So the fourth takeaway from here is the idea of reference frames. He mentions reference frames throughout. And as I understand them, they are an abstract concept for hanging information off of certain things, including models of certain things. And so we have many reference frames in our cortical columns, and those reference frames contain information. They contain models about things like a coffee cup and what that coffee cup feels like, how far it is away from our body on a table, for example, that location awareness, where it is relative to us. All that information is in these reference frames, and he even alludes to reference frames as being the thing that is how we think. So being able to move throughout these reference frames that point to all kinds of different data and objects and memories and stuff in our head that is actually what thinking is, as we move around in those frames and try to put a cohesive idea or a thought together. That's the way I understand it. What else does he say about that? 3, all human knowledge, he says, is started as reference frames. He says reference frames are present anywhere, everywhere in the neocortex. They are used to model everything we know, not just physical objects. And all knowledge stored at locations relative to reference frames. And he says that thinking is essentially a traversal between these reference frames. So it's kind of an abstract thing to think about, but that's kind of the whole point of this book, is trying to create a framework for how to understand how the brain actually works. And so why does he want to do that? Well, why does he want to understand how the brain works? I think primarily he wants to understand exactly how the brain works. Is one, because nobody does right now. He talks about the brain being like, our research into neuroscience and how the brain works is a big puzzle with all these pieces that we understand certain details about, but we don't yet understand how all those puzzle pieces fit together in a comprehensive picture, so we have a comprehensive idea of how the brain is actually functioning. Nobody knows that yet, which is fascinating. Especially when you think of that in the context of, we're trying to build machines that are better than our brains, but we don't even know how our brains work. We don't even know how our brains work, but we are trying to build machines that are better than how our brains work. It's kind of weird. Like, how do you expect that to happen? It's almost like that's not going to happen until you fully understand how your brain actually works, how thinking actually takes place, how memories take place, what it means to be intelligent, and how your brain makes you intelligent, and better idea of what consciousness is. Is consciousness a thing? And so understanding how the brain works is a stepping stone for helping humanity learn how to build an artificially generally intelligent machine like humans. Like we have right now aren't even up to par for how a 5-year-old thinks, much less a dog or a cat. And I think about my animals all the time. I have a cat and a dog, and I think, what are they thinking about? How they're able to move around their environment. They're able to plan ahead. They know when I walk away and aren't looking at them, that they could go steal food. And so they're planning and they're thinking ahead and they're watching me. These are actually very intelligent creatures relative to how machines work. And so, thinking about, we're trying to build artificial general intelligence when we can't even duplicate the sneakiness of a cat, for example, in silicone. So we're a long way. A lot of interesting thoughts there. First of all, silicone is so fast. Transistors are so fast. They can process millions of messages a second. Compared to wetware, compared to our neurons, who can only deal with messages at a rate of 5/1000ths of a second. Our wetware compared to computer hardware right now is so slow, but our brains are so much more intelligent. So I also saw something totally different watching a Graham Hancock television show, and he was mentioning how the Mayans had a different numeric system. So we in the Western world use a 10-based numeral system. The Mayans use a 20-based numeral system, and their calculations for the calendar were so much more fast and so much more advanced compared to what we can do today. And this is the Mayans way back when. Computers, on the other hand, are a 2-based numeral system. They're basically binary, ones and zeros. So it makes me think these two things combine, and other things as well, that maybe there's a whole lot of change that needs to take place from an infrastructure level, from not only the hardware, but from how we think about software and how we build how we can create more efficient machines, not faster machines. But you know what's driving it is we have to sell more and more hardware. We have to sell more and more GPUs. We have to build more and more data centers. Fairfax County is building these huge data centers, using up all our water and all our land to sell more and more hardware because we're building all these hugely inefficient artificial intelligence systems and services. So this is the age of efficiency. We really need to look at efficiency now, I think, in terms of the steps forward, our future for how we're going to approach building artificial general intelligence. So that's my take on this book, on these two books. Jeff Hawkins, he probably totally disagree with everything I just said, but that's kind of what I'm thinking. Take it or leave it. Thanks for watching this episode, and we'll see you next book. Over and out. Hey, it's your boy JC one more time. I just wanted to give a shout out to some of our sponsors, specifically Avoca Farm. They are located in Paris, Virginia, and they make the best Wagyu beef in all of Virginia. You can find them online at avocafarm.com. That's OVOKA farm.com. Also wanted to give a pitch for our Viking Rose indoor rowing software platform.
Viking Rose. Row on adventure.